In this video lecture, we're going to talk about what is chain of thoughts, where chain of thoughts has been used, how we can use it. This video is going to be all about chain of thoughts, end to end, A to Z. You're going to learn about that in detail with examples in a fun way. It's going to be great explanation. Together, we will be learning about chain of thoughts. Keep watching. So let's start. Today, we will be talking about what is chain of thoughts. So chain of thoughts is one of the very important concepts of large language models, or LLMs these days. It's been introduced by Google into our paper. That's all we're going to be discussing in this particular video. Let's start. So if I give you an example and try to understand with an analogy or method, that if I give you some problem that I have given you 5 balls of different colors in different sizes, and if I ask you that you need to bifurcate it or distinguish it or differentiate it based on the size and the colors. So your first approach would be that you would be like you are having 5 balls, 3, 4, and 5. This is red, blue, and green. In that case, when I ask you that you need to make a group of these 5 balls, so your first step would be, like step 1 would be that if you are taking color as a preference, it all depends on your intuition and your idea. If you are taking color as a preference, you would be taking red, this one, and yeah, these 2 are red. So you have taken color as a preference and bifurcated or grouped these 2 together. And then for the second step, you would be going for blue and blue. So it's blue and blue. Like these 2 groups will be made like blue and blue. If you're doing it by the preference of color, and green would be left out. Like green would be the one who's going to be left out. So we have made 3 groups. So just to understand this methodology of how we have worked on this, so the first step was that you have understood the problem statement, like what I asked and how you need to approach it, what would be the proper steps and proper directions, and also you would be saying that, what could be the particular feedback you would be receiving at each and every step. So for the first time, you took color as a preference and just saw the color. So red together, blue together, and green was left out, so since it was a unique number. So this process of human intelligence or natural intelligence, that when you see a problem statement, you try to break it to bits and pieces, more simpler steps, and do that in a more sophisticated and a more structured way. That's the process of chain of thoughts. Exactly, it's been mimicked into machines, systems, large language models, by taking inspiration from how humans solve a problem. That's called chain of thoughts. Let's try to define in a more formal way what is chain of thoughts. I hope you have, understood till now. We are taking intuition and methodology to understand all of what we're going to learn in this video. Let me formally write about chain of thoughts. So like traditional machine learning models, or even some early large language models, fail often when they need to do multi-step reasoning. So earlier, what happened is, like when you were supplied a problem to any traditional machine learning model or large language model in the initial phase of the revolution, these used to, get confused or get perplexed when a problem statement was put up. Like, you need to solve this problem, you need to do this and that, and like multiple tasks together. So they got confused, like how we need to approach it, because they got overwhelmed. So it was a lot of things thrown out, models or, that particular AI. So in that case, to solve this problem, to solve the problem of multi-step reasoning, we have introduced the idea of chain of thoughts. So what was happening before chain of thoughts was, like, it was directly jumping to answers, which was wrong. Like, as humans, we never, if we would be jumping straight to the answer, it's more of a guessing and not a proper structure or method to answer anything. So in order to solve a problem, even in real life, even if you are doing some coding or programming or some math, it's all about that you need to do proper steps and ultimately reach to a conclusion or any answer. So in the same fashion, when traditional machine learning models or earlier large language models used to just go straight to the answer and just don't think about the steps. So that was the problem which was occurring, and it couldn't be able to solve multi-step reasoning. Like if you are given a problem statement of having multiple shapes together, and you need to bifurcate them. So in that case, it's going to be just directly jumping on the solution and give some random groups of shapes, and that's all. So that was wrong, because in multi-step reasoning, you need to do some properties like based on color, based on size, based on orientation, based on dimension, based on whether the shape is curved or straight or whatsoever. So all of the multi-step reasoning need to be taken into consideration before actually coming to a conclusion. So that was the problem, which was a great problem, and we couldn't able to, achieve the intelligence level that as human were doing at that point of time. So with the time, with the advancement and the research and idea, we got to the idea of chain of thought. So now we're going to see what chain of thought is all about in machine learning or large language models. Let's move forward. I hope you're enjoying till now. I'm keeping it slow because many of the times I get enthusiastic and workaholic and speak very fast. Whenever you feel like, just tell me in the comments. I'm keeping it very calm. I'm learning a lot from you. It's more of a two-way communication process. So, as been said by Feynman, that if you want to learn a concept or any idea which is new to you, just try to understand it and go and explain to a 5-year-old kid or any friend or brother or anyone of your acquaintance, and then you would be having depth of knowledge in that particular idea. So that's what I follow. I learn stuff and explain it. You should do the same. Let's move forward. So now let's talk about chain of thought's definition into like what is the current state of art. So if I talk about chain of thought, so it's a breakthrough. It's a breakthrough technique that encourage the model to think aloud, break problems into steps, and reason like humans. So as we discussed, this is the formal definition of chain of thought. So what happens is it's a breakthrough problem, like a very unique and empirical approach where we are encouraging to divide the problem into simple bits and pieces. Like if this is a large brick and you need to break it, so what you would be doing? You would be doing smaller bits and pieces, like you would be dividing by this, so it's going to be two shapes. Then you would be doing like this, so it's going to be like this and this and this and this. And ultimately, if you want to divide like this, so it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So what we're doing is, at the end of the day, that you are dividing your problem into bits and pieces. So in the same fashion, in the same manner, you divide your problem statement or any idea in machine learning or in agentic AI or large language models, you are encouraged to divide the problem into smaller bits and pieces so it can think aloud. And as humans approach a problem, as humans do any problem solving or analytical skills, that's the same thing that's been trying to reproduce in the chain of thought. So this is the formal definition of what a chain of thought is all about. So I hope it's been clear till now. Let's move forward. I'm keeping it slow. It's going to be great, when we go on more advanced topics, you would be enjoying a lot. So this is chain of thought till now. Okay. So now we're going to understand or look at how the steps have been taken into consideration. So the first step. As humans, when we do things, what we do is we understand the problem. Like understand what has been happening, what's the reason, what we need to do, what are the steps involved. So understanding the problem, like the problem and where we need to reach, like initial and final position. So that's the basic idea of understanding the problem. Second of all, if I talk about the second step, it is about breaking into thoughts. So this is the second step in chain of thoughts, that you need to break your problem into small bits and pieces and keep it as small as possible. And that's how we can make it more optimized in our solution. The third step after breaking it into smaller bits and pieces is solve each part. So the next step is solving each part. That means that you need to solve each and every small component together, and then it could be more focused, more optimized, more to the point, and as per expectation, as how we humans do. So it would be also good for, like backpropagation, or if you encounter some error, you can simply go to that particular block and solve it, apart from, treating all of that colossal or opulent picture at once. So it would be easy for you to solve the problem on a miniature level. This is the third step. If I talk about the first step after solving each part, it would be combining all together. So what is happening is you need to break this block into 5 small blocks. That's your problem statement. Next part, breaking into small parts. So now it's the exact type of how you would be breaking it to get the 5 best shapes possible. So, like we can do like 1, 2, and 3. So these are my 5 parts. So I'm just giving you a very layman example to understand this problem statement. Once we do that, we are having 1, 2, 3, 4, and 5. Like we are having 5 blocks that we can, treat as one independent entity and solve that, like 1 and 2 and 3 and 4 and 5. So if any problem occurs in this one, it won't affect this or this or this or this. So it's going to be independent entity as a whole. And then after, since we want to go back and combine all together how it was, we can do, combine all of that together and convert into the box that we were having in the starting. So this is the approach of state of thoughts of how we break to a problem. So this was been given to human intelligence by God. So this was given to human intelligence by God, and we are reproducing it into AI models for reasoning, into LLMs. Like in LLMs, this is the concept that's been used for multi-reasoning problems. So this is how human intelligence has been reproduced into large language models. And it was the natural intelligence by nature or by God. And ultimately, we are using it into ChatGPT and Gemini and all of different large language models. So this is the ultimate picture of how chain of thoughts work. I hope you have understood till now and you're enjoying the video. Let's move forward about a few other topics that's been important into this. So let's take examples and understand this, like how these pictures, like I was giving some layman examples. Now take more math examples or more analytical examples to understand this problem statement and how we become reaching that conclusion. So if I ask you regarding this problem statement, 23 multiplied by 47, this is the question that I'm asking you. So what you will be doing is, like, as a human, you would be just calculating and giving answers. Some random answer might be possible, like you would be guessing. Like in case of guessing, without calculation and breaking into more simple steps, you would be just answering some random, like might be 500. Just a random guess could be something that you can give immediately as you see the problem statement. But this is wrong. This is not how human should approach a problem. So it's all about guessing. So that's why guessing has been aborted, or it's not being promoted into competitive examinations, because ultimately you are just guessing, and there are not fair chances of getting it right. That's the reason guessing is not something that which resonates with human nature. On the contrary, if I talk about human nature, what human should be or must be or would be doing is that you can do 23 asterisk 4 or 40 plus 23 asterisk 7. That's something you can do. So what you're doing is you're dividing this 47 into 40 plus 7, and ultimately dividing 23 by 40 and by 7. So it would be a small, easier problem, an easier approach for you. Why? Because you are having 0 at the ones place. So simply now you can multiply 4 by 3 and 2 and get a solution. So for this first term, the answer would be 920. For the second term, the answer would be 161. So 920 plus 161 is much more easier to calculate rather than 23 asterisk 47. Now when we get the answer, it is 1081. Now you can see the difference. When we guessed, when we assumed, when we predicted, just by the random guess, we got 500. In actuality, or the real human intelligence work of steps and, like bits and pieces, and ultimately solving each and every component, combining together everything in getting the answer. So it's right, it's more optimized, it's more structured and streamlined. So that's how, chain of thoughts work. That you need to divide the problem statement into more smaller parts, break it down, like from a polymer in chemistry, you need to come to a monomer, like small single units, and solve it, ultimately getting the solution. So this is how example has been considered into chain of thought. So this is how chain of thoughts work. Chain of thoughts work into machine and large language models. This is called hallucination. This is called hallucination in machine learning or in large language model. It's all about the guessing thing. It's all about some random stuff, not having exact idea, not having exact answers. So that's the part of guessing, but we would be focusing on chain of thoughts. That's how humans have been calculating and understanding the problem statement. So I hope this has been clear to now. Let's move forward on the next step. I hope you guys are enjoying, and I'm keeping it slow. Rather, I speak a lot fast many of the times, but then too, I'm thinking to keep as slow as possible to make you guys understand. It's a great experience for me, learning from you guys. Let's move forward and talk about more technically in large language models how chain of thoughts work, like how CO2 works. So what happens is, like how CO2 works into large language models. We have seen the example, we have seen the theory, we have seen some layman examples to understand a very basic and intuitive way. Now let's go to a more structured and technical content about how CO2 works into large language models. Let's have a look. So what happens is, like when LLMs are being trained to generalize text, like this is your large language model. If you don't know what is large language model and you want to understand this, call with me out. I'm going to make a separate video lecture about large language models and how it can be used to do multiple projects and ideas and your day-to-day tasks like ChatGPT or Gemini from Google. What happens is, large language model has a very unique and very important component that's called prompt. You might have heard of this buzzword prompt engineering, doing prompt to generate ideas, text, projects, responses, your tasks to be done in a faster way. All of that. So that's been done by prompt. What is a prompt? Let's understand that. So a prompt is explaining reasoning step by step to activate internal representations. So what happens is, when you give a prompt to a large language model is a humongous amount of corpus which is containing vector, like it's contained text into numbers, and these numbers are called vectors. So vectors are being stored into large language models, and then based on computation and permutation, the response has been outputted or outcasted. That's a separate topic. But now, as of now, we are talking about prompt engineering or prompt. What is prompting? So prompting is an art, technique, or a way where you explain a step-by-step approach to activate internal representations of a large language models. What's that mean? Or what could be the internal representations? It could be like better accuracy. It could be better accuracy on complex tasks, like achieving a greater accuracy, a more precise method to, like do tasks which is very complex and having a lot of data in complexity, all of that. So by prompt engineering or by giving a very rich prompt, you can achieve great accuracy. That's the first point. On the second, we are having, it's about generalization to unseen problem. It's generalization to unseen problem. Like, since you would be having a great prompt, like a great method or a great way to put down a problem into bits and pieces, so ultimately for a newer problem or problem that large language model haven't seen or it's new to the system, ultimately those problems also could be taken care of by treating into a proper structure and breaking the problem and try to focus on each and every component. when each and every component has been solved, it's going to be combined together and ultimately put up as a solution. So all of that, it's been generalized on unseen problems. So this is also one of the, I would say, byproducts or techniques used in prompt engineering to get a generalized solution on unseen problem. Moving forward, if I talk about the third one, it's about improvement on interpretability. Improvement on interpretability. So what happens is when you want to interpret some things, it's really good that if you are having a great prompt, it's really idealistic to get a good response, and ultimately you can interpret the information from that response. So that's how we get a great response, like in ChatGPT, when you're giving a prompt and you're getting a response, so you can make sense out of that response. So what that means is that your prompt is good, and ultimately this prompt, like the prompt given a good outcast, structured, streamlined response based on which you can make decisions and like discuss, idealize, and move forward. So that's the improvement due to the reasoning of prompt engineering, like giving a great prompt. So this is the process, like how COT works. Like this is the complete process of COT. COT is all about, like chain of thoughts is all about breaking the problem statement into bits and pieces and ultimately solving each and every entity together, like separately, and combining together as a solution, as a complete solution. So that's the idea of chain of thought. So this is the actual technical implementation of how it works. I've just shown you the, like the mature examples of what we have learned over the past with a layman example, a general example. So this is a technical explanation for COT or chain of thoughts. Let's move forward and look around the next topic, which is upcoming, about prompt comparisons. So I'm going to show you how a good prompt has been supplied, what's the difference between them, how we can generate a good prompt, how to give to machine to get the best result as accurate and as precise as possible. All of that we're going to look at in this section of the video lecture about how a prompt should be given. Okay, so prompt comparison. We're going to talk about prompt comparison. Let's see. So first of all, if my task is, I'm going to write my task. If my task is that if there are 3 cars and each has 4 wheels, I got 3 cars, each got 4 wheels. What are the total number of wheels? This is my question. Like, this is my task that I have given to the system. There are 2 variations. Let's see how it's going to work. The first of all, like without chain of thoughts. If we are not having chain of thoughts, what is chain of thoughts? Again, just to revise, studying the problem, breaking it into bits and pieces, solving each bit independently, combining all of the bits together into a complete solution. This is chain of thoughts. If we are not applying chain of thoughts to this particular problem statement or task, what would be the response like? Let's see. So the response could be like you are having 3 cars and you got 4 wheels in each. Might be 8. Like 8 could be total number of wheels for 3 cars. That could be a hallucination. So this is the process of hallucination, as we discussed in the starting of the video. So this is hallucination. Just some random assumptions or some random ideas to just give the response as soon as possible, rapidly, without actually thinking or reasoning or doing some computation in mind. It's all about like just giving the response as soon as possible, and that's what most of the students do. But that's not the right way. The right way is that you study the problem, break into bits and pieces, and ultimately solve it and combine together. So in that way, that's the principle of COT or chain of thoughts, and that's how a natural human intelligence works. Now let's see, this was without COT. Now with COT, like chain of thoughts, it would be, I got 3 cars, each car got four wheels. So for first car, it's going to be 4 wheels. For the second car, it's going to be 4 wheels. For the third car, it's going to be 4 wheels. So in totality, it's going to be 4 plus 4 plus 4. That's going to be 12 wheels. This is how chain of thoughts works. So this is the basic difference between how chain of thoughts work, and on the contrary, how without chain of thoughts we are solving a problem. It's more of an hallucination, assumption, prediction, just more of our imagination, and that's all. But in reality, you should be focusing on chain of thoughts. So this is the prompt comparison I've just given you, that with chain of thoughts, how it could answer, and without that, how it can answer. this is a brief comparison between the two. Let's move forward and try to talk about what are the types and variation and categories into chain of thoughts and how we take them forward. Let's see that. So it's going to be about types of chain of thoughts in this section of the video. Let's see that. Yep. So types of COT. Okay, moving to the first type. The first type of COT is manual prompting. It's manual prompting. So it's also called few shot COT. Let me give you an example and tell you about how it happens. So it's been said that given the model examples that include reasoning steps. So what happens in manual prompting or few-shot COT or chain of thoughts, that you give example, you supply examples to the machine or to the system in the format of chain of thoughts, and based on that examples and ideas, your model do the reasoning. So it's like that if you are having a model, you have supplied 1, 2, 3, 4, 5 examples in process to do the processing, and ultimately a new thing comes. So based on these 5 examples, your machine or model would be outputting the answer based on these 5 models, like based on these 5 examples or scenarios. So that's how manual prompting works. So it's having like few restrictions. It's not going to be independently open or not having a wide spectrum of knowledge because of the very constrained parameters and features. Since we have supplied only few examples, or even if we are supplying multiple examples, you would be having a definite number or distinct number that couldn't be infinite or like multiple or multi-million combinations. That's not possible. First type of chain of thoughts. Moving on to the second one, let's see the second type of chain of thoughts and what it's called. The second one is about zero-shot COT, or WIT. It's also termed as WIT triggers. WIT triggers phrases, like having a trigger phrase in a prompt or in the chain of thoughts. That's called zero-shot COT. Let's take an example, like adding a trigger. So what could be a trigger? A trigger could be, let's think step by step. So in the prompt, what you would be saying that for any particular given input, you would be saying that for this particular input, I want to think step by step. So you have written that for any problem, just try to take it step by step. So it's a trigger phrase for every input. You would be having that filter upon it, and ultimately that's going to be taken care of by step-by-step process. So that's how zero-shot learning works, where you're supplying some triggers or some phrases or some sentences based on which your problem statement would be worked upon and produce a solution. So that's the second type of zero-shot COT learning. Third one. Let's move to the third one. That's called auto COT. What is auto COT? So it's more of an automatic prompt generation. So now we are coming to automata or autonomous systems. So like this is the COT which is having ultimately everything automated, like ultimately generating the prompt. And this is current state of art which has been used like these days, automatically generating prompts and doing the task as required. So what happens in this one is like we use large language models. We use large language models or LLMs to generate its own reasoning examples. It's also called meta prompting. This is the process of meta prompting. I'm going to talk more into it, but just as of now, it's more, I would say, robust, more generic, more advanced. So when you are having a large language model like GPT, like ChatGPT, for example, and you give an input to that large language model, ultimately large language model reasons to itself and generate different chain of thoughts. And based on that chain of thoughts, because you have also seen in these latest models like DeepSeek or ChatGPT 2 that it's having a thinking mode. Like it's been thinking that what to do, what not to do, where to fetch the data from, where to leave it, all of that. So that's the thinking mode, and that's called auto chain of thoughts. So ultimately, it's doing everything on its own and giving you the response. So it's more like reasoning of the LLM, for the LLM, in the LLM, by the LLM. So it's that, like the auto chain of thoughts in this scenario. So this is the more productive and more optimized solution for chain of thoughts, apart from this and this, because these were some early generators in the market, but now, as of now, like it's all auto COT that's been used these days. So this is how we have automated processes, and this leads to Agentic AI, where we have connected all of the systems, all of the APIs, all of the database together in achieving different tasks just by a simple prompt. So that's the power of auto COT, or that's the power of chain of thoughts about how we can deduce these solutions just by reducing the prompt into bits and pieces and ultimately solving and getting the best solution possible. So that's how types of COT has been termed as. Let's move forward and talk about few real tasks and real scenarios of chain of thoughts. I hope you guys are enjoying. Please share your feedback in the comment section, and also tell me like what could be the changes that I need to incorporate for my future videos, and also about what are the topics that you want to hear from me in form of AI or some tech talks, or my experience as a data scientist about research, or what I'm doing, like how a data life of my goes, like all of that. So we can also focus on that. Apart from that, let's move forward and see COT in real tasks, like how it does in the real world environment. Let's talk about that. So few of the examples could be math word problem. So COT works great, like you might have seen that on ChatGPT when you supply a numerical or physics question. It's just like it's been great at solving and understanding that what you are saying and what are the numbers associated to different SI units. What is the best SI unit I need to answer in, and all of that. Like if you're talking about force, it's going to be Newton, of course. If you're talking about pressure, it's going to be Pascal. So all of that has been done by COT and real tasks. So this is one of the great applications of COT these days, like solving the math word problem. The second is logical reasoning. Logical reasoning, as we have just discussed regarding 3 cars having 4 wheels each, and how many total number of wheels will be present in 3 cars. All of that logical reasoning has been taken care by COT in large language models. This is the second application which has been greatly done. The third one is common sense question and answers, like common sense question and answers. If you're talking about, like, if I say that I want my elephant to, sit on an ant. So do you think it's logical? Do you think it's really good that an elephant can sit on an ant? No, that's not logically possible. That's a common sense that it's not possible. Or if I asked regarding, like, it's 12 noon. Tell me, when should I sleep? So that's a question, like, it's 12 noon in the day. So of course, that's not the time to sleep. So all of these general questions or general logic questions, which could be answered just by the common sense, all of that could be also taken care of by chain of thoughts and real tasks by these techniques and methodologies. So these are the few tasks that has been taken care of by COT in real life. Of course, we are not using manual prompting or of zero-shot COT. Rather, we are going with and moving fast forward with auto COT that's been ultimately generating its own reasoning for the large language model, applying it, and ultimately solving these kind of problems. So all of that, it's been taken care by COT. Let's move forward to the next topic into COT, which is very interesting, and we're going to see about what's happening behind the scenes, like what happened behind the scenes. In this video, I won't be going mathematically deep, like in deep down, what exactly having the vectors and numbers and 3D vector space and all of that. I'm just going to show you some theoretical part of what happens behind the scenes. What happens behind the scenes in COT. So the first thing is it aligns it aligns with transformers. So what is transformer? Transformer is going to be a complete video lecture. If you want, I can make a complete video lecture on it. It's going to be coming for sure. Yeah, so it aligns with transformers. It aligns with transformers autoregressive nature. So that means that you are predicting one token each time. Like if I am having some sentence, my name is Daniel. So if this is a sentence, so in autoregressive models, or the nature of autoregression in transformers is going to be predicting each token at one time. So it's going to be like predicting each token one time. That's the nature of transformer autoregressive nature. That's what I'm talking about. It's going to be a complete video lecture. That's all going to be covered. It's going to be all covered. Don't worry. Moving forward, the next one is it provides semantic scaffolding. It provides semantic scaffolding for reasoning. Yeah, so for all the reasoning tasks, logical tasks, whatever you do, whatever you tend to do, all of that logical reasoning and all of that is being taken by COT, and it does that in a very efficient way, like using your semantic and how you do it, like sentiment and all of that. That's all been taken care of by COT in this particular area. If I talk about the next, what happens behind the scenes, it's also talk about it helps model build intermediate representations before committing to an answer. So it says that it helps models build intermediate representations before coming to an answer. So it's all about like different variations of formats and augmented answers that could be, could be outputted as an result. Before all of that, the model actually understands and generalizes like what could be the thing that need to be represented and committed to as an answer before actually supplying it to the user. So when you ask a question to ChatGPT, it's going to take a bit of time and generate an answer. So in that case, it's going to look for every possible solution or every possible output that could be your answer, and you get a response. Many of the times you might have seen that you get two responses, like 1 and 2, and you need to choose one. So when you choose one, it's going to be adjusting its weights and biases and parameters that for the next time, when you want something, what kind of nature, what kind of representation should I take here into consideration to give as a response? So all of that has been done into the behind the scenes of chain of thoughts. So this is the third thing, which is really important in chain of thoughts process. Next, move forward. So it's not about, exactly changing of weights, rather it's all about how simply we can generate answers more efficiently. So that's how what happens in the third third definition of this behind the scenes COT. Let's move forward. Yeah, let's see next what's happening. So now it's going to be some limitations. Like for the complete video, I was talking about the advantages, the pros of COT, and how powerful and how colossal or sagacious this COT methodology is all about. But let's talk about what are the few limitations, because nothing is perfect. So it's going to be having some cons or some disadvantages or some limitations, I should say. So let's talk about limitations of COT. What are the limitations to COT? Let's see that. So the first limitation, it doesn't try all logic errors. So I was talking about the limitations. The first limitation, it doesn't try for all logic errors. Like it could be flawed reasoning some of the times. Can't still occur. Like it can still occur. Like some of the times it's not reasoning well, it's not understanding properly. All of that could occur because it's a machine, it's an artificial thing. So there is a possibility that it could, have few limitations. Like the first one could be it ain't reasoning well. Like some of the times it could hallucinate or can get confused or get perplexed. That could be a limitation to this chain of thought module. Second of all, if I talk about the second limitation, is it can lead to verbosity. It can lead to verbosity or hallucination hallucination in open-ended environment. Like what I just talked about is about hallucination. Like there's nothing present, but then too it could reflect that there is something coming up. Like for example, in self-driving cars, if you're driving a car and sitting at the back, and there is no pedestrian or there is no vehicle in the front, that then too it could hallucinate and generate problems. And if you're in a car, it could really be a tough time for you. So it can lead to hallucinations of the times. Though people and researchers are working on it, but then too few hallucination is a part of the game, like in the current state of art. If I talk about the performance, so performance depends on prompt quality. Yeah, that's an important thing to focus. So the third thing is how structured, how rich prompt you supply to the large language model. That's something that is really important. The more structured, the more streamlined, the more rich prompt you supply to the large language model, or as a COT, that's something which is going to be completely changing your ultimate picture. If you're asking something and if you're not supplying very structured, very rich, very reasoning prompt, that ultimately you won't be getting the response that you are expecting. So make sure that you are supplying some great prompt. If you want a video on great prompt engineering, how to supply a great prompt to large language models, I can make a complete video lecture on that. But till now, we have seen about COT, what is COT, how it works, how it resonates with human intelligence, how COT got inspired by human intelligence and applied to large language models, and even it's one of the applications of agentic AI these days. After that, we have talked about what goes behind the scenes, what are the limitations, how we can improve it, what is the quality, how it got inspired from auto-regressive models, why it hallucinates, all of that. So we have seen quite a bit of content on COT, and I hope you have enjoyed it. So this is the first time I'm making a video on COT. I hope you got the idea and notion. If you would, I can also show you practically how it's been done on computer screens. But what I like is more of a blackboard and chalk and just engraving my ideas and thoughts processes, because I'm learning from you. That's a two-way process. I'm just telling you and learning back from you. It's more of a reflection that I'm seeing from your side. So I hope you enjoyed the video. If you enjoyed the video, do all of that formalities. I don't say about like and subscribe and share, but if you feel so, do for sure. And tell me in the comment like what next video you want, and tell me about the pace, the strategy, the way I'm presenting my ideas, the way of articulation, the pace, the delivery, and the pitch. Is it too fast? Should I need to slow it down? All of that, just tell me, and I'm going to improve with the time. I would be working on a reinforcement learning mechanism. Hope you have enjoyed it. I just say one thing at every time I make a video about irrespective of the topic I'm talking about, that you are nothing. He's everything. Keep watching. Full office.